Assalamualaikum and hi everyone. We are students from SKEE3533 course Communication Principle. Welcome to Modulation in Data Communication. We are from Group 5, Section 2. In this video, we will share with you some general knowledge and understanding about data communication, which will help you guys in completing games of Ericson Mission for later. We will be focusing in three main topics, which are amplitude modulation, angle modulation, and radio digital modulation. Here are all of the members in our group: Nur Ali Muhakim, Nur Irfa Firzana, Nur Shafika, and Nur Izaniana. Before you guys continue watching this video, please assess your knowledge in data communications by filling the questions of Part A in QR code provided here. So, let's get started.
Before we go into details, what is radio digital modulation? We at least need to know basic knowledge about what is modulation. In electronic terms, modulation is a process of varying one or more properties of a periodic waveform with a modulating signal. In telecommunication, it is a process of sending a message signal into another signal that can be physically transmitted, or we can define as a process of superimposing a low frequency signal on a high frequency carrier signal. Next, modulation consists of analog modulation and digital modulation. Analog modulation is made to transfer an analog baseband signal to an analog bandpass channel at different frequencies. Analog baseband is a low-pass signal. Meanwhile, digital modulation is made to transfer digital bit stream to an analog bandpass channel. The bandpass filter is limited to a frequency range of 300 and 3400 Hz. Analog signal is continuous waveform and digital signal is discrete waveform. Then we go through to the amplitude modulation. Amplitude modulation is a kind of modulation where the amplitude of the carrier signal changes in proportion to the message signal while the phase and frequency are kept constant. For example, audio signal. So we can see here, this is the message signal or the waveform before entering the modulation, and this is the waveform after entering modulation. The message signal will pass in through the modulation within the carrier signal and produce modulated signal. Next is amplitude demodulation. Demodulation is defined as the process of recovering back the modulating signal or the original information, or it is known as the reverse process of modulation. As we can see here, this is the amplitude modulation just now, or we can call it modulated signal. When it passes through the demodulator, we will produce demodulated signal. And this is the details inside the demodulator.
Other than amplitude modulation, there is also another technique in this data communication, which is angle modulation. Angle modulation, as known as exponential modulation. It is another well-known modulation technique that uses modulating signals to change the frequency and phase of the carrier signal. Angle modulation consists of phase modulation, PM, and frequency modulation, FM. Phase modulation is a modulation which the carrier phase varies according to the amplitude of the modulating signal. Frequency modulation is a modulation which the carrier frequency varies according to the amplitude of the modulating signal. So let's go into detail. Here are the signals for modulating PM and FM. We can see here, when modulating signal undergoes FM modulation, it will generate a modulating signal just like this. The produced FM signal here will have a higher frequency due to the positive peak of the modulating signal. Same goes for the negative peak that will cause FM signal to have a lower frequency. Next, let's see for the phase modulation, PM. When the modulating signal is rising, the resulting PM will have a high frequency. And when the modulating signal is falling, we can observe here that the phase modulated signal will have a lower frequency. Next, this is the ideas on how we can generate FF signal by using PM modulator and vice versa. From the above block diagrams, it can be shown that the generation of FM and PM signals are somehow related to each other. The modulation process is used to get back the information signal. For FM demodulator, in order to get back information signal from FM signal, PM demodulator is used and the signal is passed through differentiator. In contrast, for PM demodulator, FM demodulator is used and the signal is passed through the integrator.
Assalamualaikum warahmatullahi wabarakatuh and hello. My name is Noralim Hakim Benadek and I will be presenting radio digital modulation. Firstly, we have to ask, how about digital transmission? Digital signal can be transmitted through free space if analog carrier is used. There are three types of analog carrier that can be used. Firstly is amplitude shift key, ASK. Secondly, frequency shift key, FSK, and phase shift key, PSK. We will take a look at amplitude shift key, ASK. It is a form of amplitude modulation that represents digital data as variation in the amplitude of carrier wave. It is in a binary symbol 1 that is represented by transmitting a fixed frequency for a bit duration of t seconds in a system and a binary symbol otherwise. The picture below will show the binary data sequence, the data waveform, carrier signal in sign, and ASK signal waveform. Next, we'll be looking into frequency shift key, FSK, a frequency modulation scheme in which digital information is transmitted through discrete frequency change of carrier signal. It is used in communication system technology such as weather, balloon radio sounds, and telemetry. For example, bit 1, frequency of carrier wave become higher, so period of waveform decrease. Bit 0, frequency of carrier wave become lower, hence the period of waveform decrease. The result is shown in the graphic below. Lastly, there is phase shift key, PSK. It is a digital modulation scheme that conveys data by modulating the phase of the carrier wave. Sine and cosine of input is varied at a precise time for the modulation. A finite number of phases is used. Each phase will encode an equal number of bits. The phase of carrier is set between 0 angle or 180 angle, depending on the digital data signal that is transmitted. Phase change at the specific point, which include binary value 1 or larger, binary value 0 or binary value 0 until binary value 1. This is shown in the graphical below. This is the graphical comparison between ASK, FSK, and PSK. Also, the coding that is used in this type of carrier signal. Next, we'll be looking into multi-level shift keying. In previous digital transmission techniques, which include FSK, ASK, and PSK, will only be using one bit to represent one symbol, while multi-level shift keying uses more than one bit that can be represented by symbols. Number of binary input, that is n equal to 1, number of symbols required for n bits is m equal to 2 to the power of n equal to 2 to the power of 1, which is 1. Therefore, m equal to 2 means that one bit can be represented 2 symbols. To get in a more easier understanding, the tabulated below is shown digital signal binary input comparison to ASK, PSK, and FSK. Next, we'll be seeing the relationship between baud rate and bit rate. Baud rate is the measure of the number of change to the signal. per second that propagate through a transmission medium, while bit rate is the number of bits per second through the transmission. The formula that can be used is symbol rate equal to baud rate equal to bit rate over n, or equal to bit rate over log 2m, where m equal to 2 to the power of n. Lastly, we'll be looking into quad phase shift keying. The carriers undergo 4 changes in phase and represented as 2 binary bit data for each phase, which is 00, 01, 10, and 11. This will allow the carrier to transmit 2 bits of information instead of 1, thus can effectively doubling the bandwidth of the carrier. Usually, the angle is rated between 45 angle or 90 degree angle. The most common use is 45 degree angle. For bits in a 00 will be 45, next is 135, 225, and lastly is 315.
For this part, I'm going to show you how to begin the mission. After clicking the link, this is the first thing will appear on the page. All you need to do, just enter your email address and re-enter the same email address. Now, select your country. Don't forget to click the white box. Just want to agree that you want to do this mission. Now click continue. Up until here, there are 2 options and continue to single mission. It will appear 8 missions, but regarding to this topic, we will proceed with mission 4.
Mission 4, Data Communications. Here's a list of your tasks.
Now
within
click
this
at the
mission.
blinking
Mission 4,
icon
Data
on your
Communications.
top left,
Now select Data Transmission
and now
to do some
click
research.
to Data Transmission. You can scan the QR code to go straight to the missions page, or click the link on the description below. That's all from our group. Thank you.